Our universe is a place of constant motion, a dynamic and ever-changing expanse where nothing remains still for long. It is a magnificent cosmic ballet where galaxies pirouette and waltz across the vast expanse of space, creating a mesmerizing spectacle that has captivated astronomers and dreamers alike for centuries. Stars are born in dense clouds of gas and dust, live out their brilliant lives, shining brightly in the night sky, and eventually fade away, only to be reborn in new, spectacular bursts of energy. This cycle of stellar birth, life, and death is a fundamental process that drives the evolution of galaxies. In this grand cosmic dance, there are few events as awe-inspiring and impactful as the collision of galaxies. These colossal encounters are not just random accidents, but are driven by the gravitational forces that govern the universe. These colossal collisions are not merely destructive events. They are the very engine of galactic evolution, forging new generations of stars and shaping the universe as we know it. The energy released during these collisions can trigger the formation of new stars, breathing new life into the galaxies involved. Among the countless galaxies populating our universe, two stand out in their significance to us: the Milky Way, our galactic home, and Andromeda, our nearest galactic neighbor. These two spiral behemoths are on a collision course, destined to merge in a cosmic event that will reshape the night sky. These two spiral behemoths are locked in a gravitational embrace, destined to collide in a cosmic display billions of years in the making. The gravitational forces at play will pull them closer and closer, setting the stage for an epic encounter. This impending collision, while still far in the future, offers a tantalizing glimpse into the powerful forces that shape the universe and raises profound questions about the future of our planet and the very existence of life itself. What will happen to our solar system when these two galaxies finally meet? The collision of the Milky Way and Andromeda is not a sudden, catastrophic event, but rather a slow, graceful dance that will unfold over billions of years. This gradual process will allow us to observe and study the intricate details of galactic interactions. As these two galaxies draw closer, their gravitational fields will begin to interact, distorting their shapes and setting stars on new trajectories. The gravitational pull will cause stars to be flung into new orbits, creating a chaotic yet beautiful display of cosmic forces at work. Over time, the two galaxies will pass through each other, their stars mingling and swirling together in a mesmerizing display of cosmic choreography. This intermingling of stars will create new patterns and structures within the merging galaxies. This intricate dance will eventually culminate in the merger of the two galaxies, forming a single, colossal, elliptical galaxy. This new galaxy will be a testament to the dynamic and ever-changing nature of the universe. This essay will delve into the science behind this epic collision, exploring the nature of galaxy mergers, the forces that drive them, and the outcomes they produce. We will examine the characteristics of the Milky Way and Andromeda, understanding what makes these galaxies unique and how their individual properties will influence the outcome of their collision. We will also look at the expected timeline of their encounter, mapping out the stages of their collision and the changes that will occur over billions of years. We will also examine the potential effects of this collision on our solar system and planet Earth, considering both the challenges and opportunities presented by this momentous cosmic event. How will the collision impact our solar system's stability and the future of life on Earth? Finally, we will reflect on the profound implications of studying such a collision, highlighting its importance for our understanding of the universe and our place within it. By studying these cosmic events, we gain insights into the fundamental processes that shape the cosmos and our own existence within it. Galactic collisions are a fundamental aspect of the evolution of the universe. These grand cosmic events have been occurring for billions of years, shaping the very structure of the cosmos as we know it. Far from being rare occurrences, these cosmic mergers are thought to be relatively common, shaping the growth and development of galaxies over billions of years. In fact, our own Milky Way galaxy is on a collision course with the Andromeda Galaxy, a cosmic event that will unfold over the next few billion years. When galaxies collide, they don't simply smash into each other in a chaotic mess. Instead, they engage in a slow, intricate dance influenced by their immense gravitational forces. Instead, their mutual gravitational forces create a complex and mesmerizing interaction. This gravitational ballet can last for millions of years, with galaxies passing through each other multiple times before finally merging. The immense gravity of each galaxy tugs at the stars, gas and dust of the other, distorting their shapes and sending them careening into new orbits. This process can create stunning visual phenomena, such as tidal tails and bridges of stars stretching between the interacting galaxies. Imagine two swirling whirlpools slowly approaching each other. As they draw closer, their currents begin to intertwine, creating intricate patterns of flowing water. As they draw closer, their currents begin to intertwine, creating intricate patterns of flowing water. This is similar to how the gravitational forces of colliding galaxies interact, weaving together the stars and gas in a cosmic dance. Similarly, colliding galaxies create breathtaking streams of stars and gas, stretching out across vast distances like cosmic bridges connecting these celestial islands. These streams can span hundreds of thousands of light years, creating a spectacular sight in the night sky. These interactions can trigger intense bursts of star formation as clouds of gas and dust are compressed, igniting the birth of millions of new stars. This starburst activity can light up the galaxies, making them some of the brightest objects in the universe. The ultimate fate of colliding galaxies depends on their relative sizes and speeds. The dynamics of these collisions can vary greatly, leading to different outcomes. Sometimes a larger galaxy might completely engulf a smaller companion, absorbing its stars and gas into its own. This process can significantly alter the structure and composition of the larger galaxy. In other cases, two galaxies of similar size might merge over billions of years, eventually coalescing into a single, larger galaxy. This gradual process can lead to the formation of new structures and features within the resulting galaxy. These mergers often result in the formation of elliptical galaxies, which are characterized by their smooth, oval shapes and older stellar populations compared to their spiral counterparts. Elliptical galaxies are typically found in the centers of galaxy clusters, where collisions are more frequent. The study of galaxy mergers is crucial for understanding the evolution of galaxies, including our own. By examining these interactions, astronomers can gain valuable insights into the processes that drive galaxy formation and transformation. By observing these cosmic interactions at various stages, astronomers can piece together the history of galaxy formation and gain insights into the processes that drive the growth and transformation of these celestial giants. This knowledge helps us understand not only the past and present of our universe, but also its future. Our very existence is intimately connected to a vast, swirling city of stars we call the Milky Way. This magnificent galaxy, stretching over 100,000 light-years in diameter, is a cosmic marvel that has fascinated humanity for centuries. This barred spiral galaxy, our cosmic home, contains hundreds of billions of stars, vast clouds of gas and dust, and countless other celestial wonders. Each star, each cloud, and each particle of dust plays a role in the grand tapestry of the Milky Way. At the very heart of our galaxy lies a supermassive black hole, a gravitational giant that influences the orbits of stars and the dynamics of the galaxy itself. This black hole, known as Sagittarius A*, has a mass equivalent to millions of suns. From our vantage point within one of the Milky Way's spiral arms, we gaze upon a hazy band of light stretching across the night sky, a breathtaking vista of our galaxy's disk seen edge-on. This band is composed of billions of stars whose collective light creates the Milky appearance. The Milky Way's structure is characterized by its central bulge, a dense region populated by older stars. This bulge is a bustling hub of stellar activity, where ancient stars reside, telling the story of the galaxy's early formation. Surrounding this central bulge is the galactic disk, where spiral arms wind outward, dotted with young hot stars and glowing nebulae. These arms are the sites of ongoing star formation, where new stars are born from the remnants of previous generations. These spiral arms are sites of active star formation, where clouds of gas and dust collapse under their own gravity, giving birth to new generations of stars. This process of star birth and death is a continuous cycle that has been ongoing for billions of years. Our Sun, a rather ordinary star, resides within one of these spiral arms, orbiting the galactic center at a distance of about 26,000 light-years. This position within the Milky Way provides a stable environment for our solar system. The Milky Way, like all galaxies, is not a static entity. It is a dynamic and evolving system constantly rotating and interacting with its surroundings. The stars, gas and dust within it are in perpetual motion, creating a cosmic dance that has been ongoing for billions of years. It is a dynamic and evolving system, constantly rotating and interacting with its surroundings. The gravitational forces at play within the galaxy ensure that it is always in a state of flux, with stars and gas clouds moving in complex patterns. Over its long history, the Milky Way has likely experienced numerous minor mergers with smaller dwarf galaxies, incorporating their stars and gas into its own. These mergers have contributed to the growth and evolution of our galaxy, adding new material and altering its structure. These past collisions have shaped the Milky Way into the majestic spiral galaxy we observe today, and its evolution is far from over. Future interactions with other galaxies will continue to mold and transform it, ensuring that the Milky Way remains a dynamic and ever-changing entity. As we continue to study the Milky Way, we gain a deeper appreciation for the vastness and complexity of our cosmic neighborhood. Each discovery brings us closer to understanding the intricate workings of our galaxy and our place within it. Understanding our own galaxy provides a crucial context for studying other galaxies and unraveling the mysteries of the universe at large. By exploring the Milky Way, we not only learn about our own origins, but also gain insights into the broader cosmos.